Hello everyone, today we are going to learn divisibility test of 10 to the power n plus 1. If we keep n is equal to 1, it is 11. If we keep n is equal to 2, it is 101. If we keep n is equal to 3, it is 1001. I hope everyone is aware of divisibility test of 11, so we'll go directly to the divisibility test of 101. So first of all, let's have a look at a number. Let's take a number, that is number is 10. Let's take number is 10, 20, 30, 40, 50. We want to divide this 10 digit number by 101. So how we can divide? Let's have a look at it, everyone. 101 is nothing but 10 to the power 2 plus 1. This is 10 to the power 2 plus 1. Over here value of n is 2. So we are supposed to make a group of two digits from right hand side. We are supposed to make a group of two digits from right hand side because n is equal to 2. Now starting from rightmost group, we are supposed to add alternate groups. Starting from rightmost group, we are supposed to add alternate groups, and let's call this addition as S1. Let's say over here S1 is equal to how much? 50 plus 30 plus 10, that is equal to 90. And let's add the remaining alternate groups. The addition of remaining alternate groups over here is how much? 40 plus 20, that is equal to 60. Let's call it as S2. S2 is equal to 60. So over here the remainder is going to be how much? Let's have a look at it. Over here the remainder is going to be S1 minus S2. It is always S1 minus S2. We are not supposed to subtract a smaller number from larger number. Okay, the remainder is always going to be S1 minus S2, that is equal to 90 minus 60, that is equal to 30. Let's take one more example to understand this concept in detail. Let's take another number. Let's take a number is 50, 40, 30, 20, 80 and 10. Let's divide this number by 101. Over here 101 is 10 to the power 2 plus 1. Over here value of n is 2, so we are supposed to make a group of two digits from right hand side. Now starting from rightmost group, we are supposed to add alternate groups, and let's call this addition as S1. Over here S1 is equal to how much? 10 plus 20 plus 40, that is equal to 70. And S2 is going to be how much? 80 plus 30 plus 40, that is equal to 160. S2 is equal to 160. So to find the remainder, we are not supposed to do 160 minus 70. The remainder is always going to be S1 minus S2. The remainder is always going to be S1 minus S2. In this case, that is equal to how much? 70 minus 160. That is equal to how much? Minus 110 is the remainder. Okay. But if we divide a number by 101, the remainder has to be less than 101. Okay, and it's supposed to be positive. So now let's convert. Now look at, if we divide 110 by 101, the remainder is how much? Minus 9. So minus 9 is a negative remainder. How to convert negative remainder into positive remainder? We are dividing this number by 101. So 101 minus 9 is equal to how much? 92. 92 is a positive remainder here. So the answer is 92. Now let's have a look at another example. Let's take a number as 100, 200, 300, 400 and 500. Let's divide this number by 1001 and find the remainder. 1001 is nothing but 10 to the power 3 plus 1. So over here the value of n is 3. So from right hand side we are supposed to make a group of three digits each, like this. Starting from rightmost group, add all alternate groups, and this addition is going to be how much? Add all alternate groups, and this addition is going to be 500 plus 300 plus 100, that is equal to 900. Let's call S1 as 900. Over here add all the remaining alternate groups, that is 400 plus 200. Let's call it as S2. S2 is nothing but 400 plus 200, that is 600 here. So our remainder is going to be how much? Our remainder is going to be S1 minus S2, that is equal to 900 minus 600, that is equal to 300 is the final remainder. Okay everyone, let's take another example. Now let's say the number is 500, 400, 300. then 200, 800 and 200. Okay, 800 and 100. Let's divide, this is a 12 digit number. Let's divide this number by 1001 and find the remainder. 1001 is nothing but 10 to the power 3 plus 1. Over here n is equal to 3, so from right hand side we are supposed to make a group of 3 digits each. If we cannot form a group on the left hand side, then we can add 0 on the left hand side to form a complete group. Now starting from rightmost group, let's add alternate groups. So the addition of alternate groups is going to be how much? 100 plus 200 plus 400. Let's call this addition as S1. That is going to be how much? 700. And add remaining alternate groups. That addition is going to be how much? 800 plus 300 plus 500. That is equal to, let's call that addition as S2. That is equal to how much? 1600. So over here the final remainder is going to be how much? S1 minus S2. That is equal to 700 minus 1600. That is equal to minus 900 is the final remainder. Minus 900 is a negative remainder. Let's convert this into positive remainder. We are dividing this number by 1001. So positive remainder is going to be 1001 minus 900. That is equal to 101 is the positive remainder here. This is how we can find the remainder when a number is divided by 101 or 1001. So now let's have a look at a question. The question is, find the remainder when 9748, 9748 and so on total 300 digits. This number is divided by 1001. Sorry, this number is divided by 101. Okay. So 101 is what? Tell me. 10 to the power 2 plus 1. Over here value of n is 2. So from right hand side we are supposed to make a group of 2 digits each like this. And then we are supposed to add alternate groups. Okay everyone, so first make group of 2 digits each from starting from rightmost. Okay, now starting from rightmost, let's add all alternate groups. Okay, let's add all alternate groups. So we can see that all 48s will come here. Okay, all 48s will come here. Total how many digits are there? Total 300 digits are there. We are supposed to form a group of 2 digits each. So how many groups are formed? Total 150 groups are formed. Out of these 175 groups, half of the groups, that is 75 groups are of 48, and the remaining 75 groups are of 97. So starting from rightmost group, add all the alternate groups, and this addition is going to be how much? S1. That is equal to how much? 48 into 75. And add all the remaining alternate groups, that is 97 and 97 and 97 and so on. This addition is going to be how much? Let's call this addition as S2, and S2 is going to be how much? 97 into 75. Okay everyone, to find the final remainder, what we are supposed to do? We are supposed to do S1 minus S2. 48 into 75 minus 97 into 75. Let's take 75 common. Let's take 75 common. So if we take 75 common, what is remaining in the bracket? 48 minus 97. Okay everyone, now this subtraction is how much? Let's have a look at it. This subtraction is how much? This subtraction is 49. Okay, that is into minus 49. Okay everyone, so now we are supposed to divide this number by 101. Okay, we are supposed to divide this number by 101. Okay, so what I will do is divide 75 by 101. The remainder is going to be how much? Minus 26 into minus 49. Okay everyone, now let's multiply 26 into 49. If we multiply 26 into 49, it is going to be 1274. Okay everyone, positive 1274. Now if we divide a number by 101, the remainder has to be less than 101. So now we are going to apply the same process again. Okay, same process. We are going to divide this number by 101 again. Okay, so from right hand side, let's make a group of 2 digits each. Now over here S1 is going to be how much? 74, and S2 is going to be how much? 12. So the final remainder is going to be how much? 74 minus 12, that is S1 minus S2. 74 minus 12, that is final remainder is going to be how much? 62.